unit is going to be different. So thus far, we have had functions that have looked like this, have looked like this. What's another one we did? I'm blanking. Well, we've had the linear. We've had the reciprocal, right? Actually, let me make that a different color. Do you remember this one? Oops. With this one with the asymptotes, the reciprocal function. Do we have more? Oh, yeah. I'm like, what? Which one was that? The radical function. Do you remember this one? Okay. There is one more that we did not do. Marley and Lila. Thank you. There's one more we didn't do called the absolute value one, which looks like this and like this, right? Just a positive y function. Anyway, what you will notice about all of these functions that we have worked on is that they don't repeat. There's one parabola, there's one curve, there's one of everything. Okay, put the phone away. Come on, it's a short lesson. You won't have time to do that later. Okay, yeah? So no repeating shapes. Now today we're starting to learn about a type of function called a periodical function. Okay, so in physics, we've learned about periods, which is the amount of time you need for a pattern for a wave to happen, right? So when you were doing sound, you were looking at the sound waves and how long does it take for the wave to be completed? That's a period. And then what happens when one wave is completed? Well, excuse me, I'm hiccuping. So for those of you who didn't take physics, this is what sound waves look like. And a period is from the beginning of the wave to the end of the wave. But then once one period or one wave ends, what begins? Well, another wave. Okay? And another one. And another one. And another one. Now, are these two diagrams functions? How do you know? Yeah. It passes the VLT. Okay? So today we are looking at functions that repeat themselves. And so we call that a periodic function because it repeats and repeats and repeats. That's the difference. Now, just to give you context, all of these functions are called continuous functions. Anyone remember from way back when? What's the other one? There's continuous functions. And then there's one called discrete. Do you remember that? And unit 10 is actually called discrete functions. And what a discrete function looks like is like this. It's a bunch of dots, right? And it's not continuous because the dots are not connected. So there are breaks between those dots. So these dots represent a discrete function. Everything else we've done is a continuous function. So maybe I should have called this course continuous functions with a little bit of discrete functions. All right. So let's take a look at this unit, which is called trigonometric functions. Okay. So we've had triangle trigonometry. We've had rotational trigonometry. We've had trigonometric identities. And now we're finally getting to the point where we connect it all as a function. So we're going to learn what does the sine and cosine function look like. And in grade 12, you are going to learn what the tangent function looks like. Okay, we don't do tangent in grade 11. And it's a little more complex because there are vertical asymptotes. Okay, so starting off, let's talk about periodic behavior. And periodic, we already talked about being repeating. So these are functions that have a repeating behavior. We're going to learn some new words. We're going to learn, or new terms, cycle, period, amplitude, I guess periodic. That's it. Those are the new words we've got. Okay, new terms. All right, so this function that we're looking at is a periodic function because it has a pattern of y values that repeat at regular intervals. Okay, so you have the same pattern, and those y values repeat and repeat and repeat. So one complete pattern, like if you look at this like red part, is called one cycle. Like the moon cycle. How long does it take for a moon to get from a full moon to a full moon? Okay, you can start the cycle at any point on the graph, but the cycle ends when the pattern begins again. So I could have said, I don't want to start the cycle when y is 2. I want to start the cycle at this point where y equals 0. Well, in that case, one cycle would look like that because I just have to go back to the starting point. As shown in the above diagram, a period is the length over which one cycle takes place. So a period is the unit, like the not the unit, the measurement of one cycle. Okay. Therefore, reference. If we look at the diagram above, how long is one period on this diagram? Yeah, use your fingers. Show me how many units one period takes. Are people confused? Okay. Yeah. So we've got 4 units, right? So from the start of a cycle to the end of a cycle is 4 units. Does that make sense? Okay, cool. Let's look at 2 functions, right? Both are functions. Now the question is, which one is periodic? And if they are not periodic, we have to explain why. So the one on the left, is it periodic or not? This one. Thumbs up, periodic. Thumbs down, not periodic. Bum, bum, bum. Good. So the pattern seems to continue, to repeat, right? It's like a zigzag, zigzag. However, the y values are not repeating. So I've got y is minus 1, y is 0, y is 1, y is 3, y is 5. Okay, so this is not periodic because the y values don't repeat. Whereas on the right side, periodic thumbs up, not periodic thumbs down. We got a periodic function. Why? Well, because y values repeat. Okay, and just to review, actually, let's jump right into the next one. All right, so given this periodic function, determine A, the period, B, f at 4, meaning the value of the function at an input of 4. We have to look at that. And f at 18. Folks, so let's start with the period. How long does it take the pattern to start repeating? 7 units. Agreed? Oh, the grads had their breakfast. That's going to be you next year. All right. So figuring out the period, we got it, right? That's easy-ish. Let's look at f of 4. So the input is 4. Now, is the input going to be the x values or the y values? Think back. Which one is it? If I have equations that look like this, y equals x squared plus 1, what is the output? Yeah, I'm getting this as the input. Agreed? The output is what's alone on the equation. This is output. And remember how we said that f of x is another way of saying y? So the x is the input. So what that means is f of 4 is, when x equals 4, what does y equal to? So we go here to x equals 4, find the value of the function. What does f of 4 equal to? 1. Good. Okay, now f of 18 is not as easy because we don't have this graph. So what we must do is keep in mind the period. So what we know is every 7 units, the period repeats. So every 7 units, the y value is identical. Got it? So if we take this function, I can also write it as 18 minus 7. And I'm saying minus 7 because I want to get myself back to this graph. Okay, so 18 minus 7 is 11. That's good. That's good enough for me because now I can read the graph. If I didn't get to 11 and I needed to take away another 7, then I keep doing it. What is f of 11? Well, it's also 1. Okay, I'm going to give you another one. What is going to be f of 51? So for this one, you're going to need to subtract the period multiple times until you get to something that is lower than 14. Okay, so take f of 51, and you're going to subtract 7, subtract 7, subtract 7. Pardon? 1 is way too far. You only have to go as far as 14. Okay, so f 51 minus 7. Okay, I'm going to do this in my head. 44. 44 minus 7 is 37. 30 minus 7 is 30. Minus 7 is 23. Minus 7 is 16. Minus 7 is 9. Yeah? So we could even say 51 minus whatever I minused equals f of 9. What did I minus? I minused 42? Am I making something up? I mean, it makes sense because 42 is a multiple of 7. Yeah. Yes. Come on. Okay, and what is f of 51? Well, at 9, it's 1.5. We get this? Okay, so in general, if we want to find out the value of the output or the value of the function at a given x value, we know it's going to be a repeating value. And we use this general formula where P represents the period, right? The length of the period. And N represents number of periods. Okay, so we've looked at the new terms cycle. Okay, cycle is not a unit of measure, but we can count how many cycles happened. But when we talk about how long a cycle is, we're using the word period. Okay, now let's look at one more term, which is the amplitude. How many people did not take physics here? Okay. I keep referencing to it, and that might not be fair. Okay. Anyone camp? Webbing is it's heavy, but it's a really good rope to have. All right. Okay. So I want to show you. So first of all, I'm going to create a periodic function. Okay, I'm not as good as a function. Oh, that's really ugly. Can I do better, Miss Sly? What if I just... Interference. Okay, I'm gonna try again. All right, so what I'm doing, okay, that's, I think, better. All right, maybe I'll have to do one of these. All right, so do you see that this is a repeating, actually, I've just got one. How many periods do I have here, or how many cycles? I actually only have one, but if I can do it really fast, maybe I can get more. All right, that's not what I want to show you what amplitude means. So amplitude is like a height of a function, but it's not from the bottom to the top. Okay, it is from the resting position of the function. So if I'm talking about like a rope that's swinging, I'm talking about how high does the function go from the rope. So when the rope is resting, it is here. Okay, now as I create a wave, okay, we can see how high it goes, and the amplitude is from this rope to about here. Agreed? The amplitude is not from the bottom of the wave to the top of the wave. However, if the amplitude is 1 foot from the rope to the top of the wave, well, the amplitude is also going to be 1 foot from this rope to the bottom of the wave. Okay, so what we must do to find the amplitude is we have to find the middle height of that function. So the amplitude is defined as half the distance from the maximum value of the function to the minimum value. So if I were to draw a sound wave, also known as a sine wave, then my amplitude is half of the height. Okay, that's the amplitude. So you sort of have to find out how high is the entire function from the bottom to the top, and then divide it by 2. And this formula here actually gives it to us. So amplitude is 1/2 of the maximum value of the function subtracting the minimum. Does that picture kind of make sense, the graph? Lila, people that didn't take physics, we're good? Good. All right, so here we are. Let's determine the amplitude of these two periodic functions. Okay, well, let's use A for amplitude. it's going to be 1/2 times F max. So what is the max? Well, you find the highest point. So it's giving me 4. Minus F min. What is the lowest point? Lowest point is 0, right? We're looking at the Y values. 1/2 times, 1/2 times 4 is 2. Could you have done that with your eyes? Yeah, for sure. To find this amplitude again, it's 1/2 times the max minus the min. 3 minus 1 is 4. And once again, the amplitude is 2. We good? Okay. Let's look at a word problem. Kelly is jogging on a straight boardwalk beside the ocean, right? So she's literally just, there's a boardwalk, it's straight, she's running. Okay. The boardwalk is 800 meters long, and Kelly begins jogging from one end at a steady pace of 8 kilometers per hour. Given the above information and the following graph, explain Kelly's motion. Okay, so this is like the distance time graphs that hopefully you did in grade 9. So what I want you to do is take a moment to look at that, okay, and try to understand and explain her running. Okay, I'll go over it, but you try to do this. Try to read the graph. So what did she do? How did she run? What's the zigzag thing? Yeah, how many times? Mm-hmm. All right, I'm getting, so what do we got? Who wants to tell me? Annabelle, how did you interpret this? Oh, that's a really good question. You okay?
Yeah.
Okay. Oh, okay, cool. Grab the booklet. This is the question. Does she take a break? Now, what would a break look like? Good, a flat line. Because this measure here is the distance from the starting point, right? So the starting point is a random spot. Now, if I'm at the starting point, my line looks like this. Okay, let's say she runs to the end of the boardwalk, which is 800 meters. Okay, that is this part. Okay, so she ran to the end of the boardwalk. If she took a break for 2 minutes, we would have a straight line, 4-minute break, like this or whatever, right? So that's what the break is. So did she take a break? No. What does the pink part of the graph show? What is it, Zach? It is a velocity, but what does the pink part represent? Running back to the start, right? Is she running backwards? No, she's just running back towards. So running away, running back, and then how many times did she do that whole cycle? Twice. How far? So let's write this down. She ran to the end of the boardwalk and back twice. No breaks. Although I think if we were accurate, let's say she finished her run, I think we need to add a line here, right? Let's say she finished her run and rested, like didn't go home, right? Then we would have a flat line at the end to say, oh, she's done. She's just sitting there drinking water, resting. What's the total distance she ran? What is it? 3,200? 800 times 4. 3. Yeah. Let's call it total. And do you know which one I really didn't like in physics? Displacement. What is the total displacement? 0. Isn't that like so unvalidating? Like, this woman just ran 3 kilometers, and you're like, actually, your displacement is 0. Man, it's like, really? That's not cool. So we're not even going to bring that in. That's just a physics thing. Okay, determine the period and amplitude of Kelly's motion. All right, so for period, how long does it take for the cycle to start? Again, how many minutes? 12 minutes. Okay, for the amplitude, it's going to be 1/2 times the maximum minus minimum. What's the maximum y value? 800 minus 0, right? So the amplitude is 400 meters. Sort of saying, how far away from the middle did she go? Let's state the domain and range. Okay, we can do that for periodic functions. So domain are the x values. Now, we're still talking about a continuous function. So we say x belongs to R, and x is between two values, right? So in this case,
X bigger than 0, less than 20.
right? Yeah. It's continuous, but it has a start and an end. Range also has restrictions. So it belongs to so y belongs to all real numbers such that y is between 0 and 800. So this function exists everywhere inside those restrictions.
It's like if there is a function that does not belong to real numbers.
Yes, there are functions that don't belong to real numbers, but we don't do that in grade 11. I don't even know if you look at that in grade 12. But I remember, like, in university, we absolutely did functions where one of the axes was the imaginary axis. I know, I agree. It was ugly, and I don't recommend it for anyone. All right, folks, you got homework. It's 9:50. You got 30 minutes. Choose your priorities, but like, you could probably do this homework in like 10 minutes, right? It's a nice and easy lesson. I encourage you to do that.